Alright guys, so this is ACSL Contest 1, the final topic, which is what does this program do? In this topic you're going to need to analyze some code given by ACSL. It's going to be similar to a pseudocode type syntax, and you're going to need to look at it, analyze it, and come up with what that code will actually do if it was run. So first we're going to learn what the ACSL syntax requires you to do and how it's laid out, and then we'll move on to some examples. So here I have this chart laid out where there's some Java examples of how things would happen in Java, and then parallel we have the ACSL code, which is the exact same thing translated in both different languages. And then here is a chart from the ACSL study materials website on each of the different types of statements and things, so you can follow through with these three charts side by side and see how they relate to each other. So first off we have how to actually define variables in both ACSL code and Java. So in Java we would simply put the variable and set it equal to anything that we defined it as. So in this case we defined a as an integer with the int, and then we set it equal to 20, and same thing with the string. We set the string b equal to ACSL. In ACSL code it's very similar, except we don't actually need to define it with a type. Instead we can simply just set it equal to something and it'll store that inside of that variable. So in this case a equals 20 will store the value 20 into a, and b equals ACSL will store the string ACSL into b, but we still do need the quotes to show that it is a string. Next up we have these sequential statements, which are pretty much statements that define how a method is laid out. So in the ACSL version, input and output is similar to how do we take parameters in Java and how we return things in Java. So here's an example of a method called doubler, in which we take the parameter a, which is an integer, and then we double it, so multiply it by 2, and we put that value into another variable called x, and then we return the variable x. In the ACSL code, this sort of bit of code in Java is written like this, where we take an input of a variable a, we multiply that variable by 2 and store it into the value x, and then we output the variable x. So output is synonymous with return in Java, and input would simply be the method header and then the parameters. So if you wanted more parameters, you could simply just put a comma after this variable and then continue with other variables. So for example, this could be input a, comma b, comma c, etc. Okay, next up we have the decision statements, which are probably going to be pretty important with the actual ACSL code, at least with the problems that I've seen. The bulk of the code has these if-else statements within, and the loops as well, which we're going to get to soon. So with if-else statements, they're very similar to like in Java. The only main difference is that we don't, instead of using curly braces to define the body of the if-else statements, we use a then and an end if. So in this case, the if a equals 20, then output a. This statement would then have an end if at the end of it. So with this else. And that would signify the end of the body of that if statement or that else statement. So here, instead of using curly braces, we use then and end if. So here we would start with if a equals 20, which is the Boolean statement, similar to how it is in Java. And then we would have a then, which is the first curly brace. And then we would return a, which is what we did here. So output a, return a. And then we would end that if statement. And then we'd move on to the else, and same thing. Okay. So hopefully that helped. You can take a screenshot of this and save it so that you have it to study. And then now let's move on to how we do loops in the ACSL code. Now for the loops in Java versus ACSL. So for the loops part of it, we're using for and while loops just like we do in ACSL, but the syntax is again slightly different. So for Java, we start with a variable that we define with a certain value, and then we have a condition that states when the for loop should end. So in this case, when or while I is less than 2, the for loop should continue, and whenever this is false, it should end. And then we have a increment at the end, so that the I increments every time the for loop runs. In the ACSL version, it's the same thing. We start with a variable, we set it equal to a starting value, and then we use this to operator to state how far we should go until we stop the for loop. So instead of using a conditional statement like this, we simply say I equals 0 at the start of the for loop, and we're going to end the for loop when we reach 2. Then we use step instead of increment, so we say step 1, which means every time the for loop executes, we step the original value up by how much we specify here. So in this case, we're incrementing I by 1 every time the for loop executes, just like this for loop would do with the I++. Then we have our actual body inside of the for loop. Same thing here, we have the A++. And then at the end, we would just put a next instead of a curly brace to signify the end of the body for the for loop. So we say the for loop actual header, then the body of it, and then at the end we put a next to signify that the for loop has ended there. The next one is the while loop, which is also pretty much the same as in Java. So we have the while and then our conditional, which is the exact same. But then again, instead of using curly braces, we define the body of the while loop with an end while, which just shows that that is the end of the while loop and that the body is only up to there. So in this case, we would just simply write while a is less than 2, increment a, and then end the while loop, similar to how it is structured in Java. Alright, now there's one more thing that we're going to have to go over with the ACSL syntax, and that's going to be arrays and strings. And after we're done with that, we're going to move on to some more examples. So the last syntax you're going to need to know is string and array syntax. So firstly, for array syntax, you don't really need to know much about it because most of the problems don't have arrays. However, if you do encounter one, it's pretty simple because in Java we had to define the array and then give its length and its values. In the ACSL problems, there's no syntax for it, so they'll always define the array's size and the values of the array in the problem statement itself. For actually accessing values of the array, it's super simple. So for 1D arrays in Java, we would access them like this, x, and then inside of brackets we would put the index value. It's super similar in the ACSL version, except we just use parentheses instead and also put the index of where we want our value. And then for 2D arrays, it's a similar deal, except instead of using our two bracketed values, we instead just put a comma in between the two values for our 2D array in parentheses. You can also read up about that in the arrays section over here. It has a little bit more information, but this is pretty much all you need to know for arrays in ACSL. Okay, next up for strings, there's a little bit more that you need to know for that. In Java, after we define a string, we can take segments of the string using the substring method. So for example, if we needed the first 3 letters of the string ACSL, we would use substring from 0 to 3. So it would take the first index, which is 0, and then it would go all the way to the third index, and it would not include that. So it would only take ACS as the 3 letters, and that's what it outputs. In the ACSL version, what we'd use is x bracket, and we would use :3. So what that says is if you use a colon first, we would start from the left and then take the first 3 letters. So the first 3 letters from the left is ACS, and that's what we'd output. So this is in many ways a little bit more easy to think about in the ACSL syntax even than the Java syntax, because in Java we don't include the last index, but in the ACSL version we simply just take that many letters or that many characters from the string. So in this case it would be the first 3 characters starting from the left. The second example is the first 3 characters starting from the right, and that would be CSL. To do that in Java, we would start a substring at 1, and then we wouldn't specify anything after because the substring method would automatically take the next characters until the end of the string. For the last one, if we wanted to get a specific segment of the string, we would use brackets, and then we would specify what 2 letters we would need with their index values. So 1, 2, that specifies we need between indexes 1 and 2, and it's all inclusive. So 1, 2 would give us CS, and that's what we'd get as an output. In Java, we would use substring 1 to 3 since we don't include our second value. So this would also output CS if we ran that. So that's how we get segments of strings with ACSL and Java. If we wanted to get a specific place in that value, we would simply just say something like x brackets and then the index value where we want it. So if we said 0, the output for that would be A, because the index value of 0 is a in the string ACSL. Similar to in Java, where we would simply just use x dot character at to get that same value. I'm not going to write through that, but this is how you do it in the ACSL version. And then one last thing that you need to know about strings in the ACSL is that there's a function called len, which you can use. And then in brackets, if we put the string len x, we would return the length of that string. So in this case, the length of ACSL is 4, and that's what we'd get as an output from the len function. And that might be important if you're dealing with any string manipulation kind of problems, which we're going to see in our examples soon. So those are the last two things that you're going to need to know for ACSL syntax. And now let's move on to a quick example of a problem that you might see on the actual ACSL in this topic. Okay, so let's look at this one example from the study materials website. So the question is asking, after this following program is executed, what is the final value of num? So at the beginning of the program, we see three variables that are defined. We have the string a, which is bananas, and then we have two other variables, num, which is the starting value of 0, and then t, which is another string variable, which starts as an empty string. These two variables here, they have a colon in between them. All that means is that they're separating two different variable definitions. So yeah, they're just defining three different variables at the top here. And then we move on to two for loops that we need to evaluate to find our answer. So the first for loop, it starts with the value of j equaling the length of a minus 1. So we know the length of a is just the length of the string, which would be 7 if we count this out. 1, 2, 3, 4, 5, 6, 7. So bananas has a length of 7, and then we subtract 1 from it. So j's starting value would be 6. And then we have to loop through this for loop until j reaches 0, and we decrease the value of j by 1 every single time, as indicated by step minus 1. So we have to move from 6 to 0 of j, and we have to loop through the for loop each time. So if we look at the body of the for loop, the body is asking us to add the value of a of j to t every time we loop through it. So what is a of j? A of j is just going to be the character at the index that we indicate by j. So we start at the index of 6. So when we start, j equals 6. And a of j, let's write it up here, a of j equals s, since that's the last character in the string. So we can notice that like the index 6 would land us with the s at the end. Okay, and then t would just equal t plus the s, and since it starts as an empty string, t would just be equaling s at the end of the first iteration of the for loop. Now if we go on to the second iteration, j equals 5, a of j equals the next character in the string, which would be a, and then t would equal what it is already, which is s, and then we would add on the a to it, so it would equal sa. So you might notice a small pattern here, which is that every time we loop through this for loop, we just add the next character in bananas to t, but in reverse. So all this loop is doing is reversing the string bananas and storing it into t. So by the end of this loop, it should look something like this. J would equal 0 at the end of the loop, the final iteration. A of j would be b, since that is the first character. And then t would just equal the reverse string of bananas, which is san, a-n-a-b. Okay, so this is what t equals at the end of our for loop. Now we have to move on to the second for loop. So let's delete this part. Okay, in the second for loop, we start with j equaling 0, and we have to loop until j equals length of a minus 1, which is, as we saw before, 6. So now we're going the other way from 0 to 6, and here they didn't give you a step value, so you have to assume that it's plus 1 because we're going from 0 to 6. So every time we're stepping plus 1. Okay, so we know that t equals this string. Now let's evaluate the body of the second for loop. So here you can see the body says if a of j is equal to t of j, then we add 1 to num. So num is a counter variable, and it's counting something for whenever the character is equal in these two strings. So let's list out both of the strings here. A equals bananas. Okay. Now that we have both of the strings, we can look through this for loop. So at a of j, we start with 0, so we start at the first character, and the first character of t is s, the first character of a is b, and then we check if they're equal to each other. If they are, we add 1 to num, if not, we don't. So in this case, they're not equal, so we don't add a value to num, and then we move on to the next step in the for loop. So we continue this process, and we only add 1 to num whenever the characters are the same. So in this case, if we look through each of the characters, we see in the second iteration, the a equals a, so that would be plus 1. The n equals n, that would be plus 2. The a equals a, so that would be 3. The n equals the n again, that's 4, and then the a equals the a again, so that's 5. So 5 times the reversed string equals the normal string. So at the end of the for loop, the second for loop, num would equal 5, and that is the answer. So you can see how we just went through this and then figured out the logic. We didn't even need to iterate through all these for loops every single time. Instead, if you find a pattern of the for loop, you're usually going to be able to find out how it works and then find your answer at the end like that. So this whole program, all it was doing was counting the similarities between the normal string and the reverse string. Okay, so there's other examples available on the study materials and posted in Remind. So hopefully you have a good time with this, and if you have any questions, please ask.